A very good morning to Dr. Zamri and Dr. Nazrin Shah. My name is Namanida Analaki Tueraj. My matrix ID is 211291020. Today we are here to discuss about Lab 2, Dynamic Response of Second Order System. So basically this experiment is split into two parts, which is section A and section B. For section A, we have to derive the transfer function of capacitor VOS over Vs for the electrical network shown in the figure below. And the second part of it is by applying the transfer function in section A and using step function as input, we have to plot the response of the system by using Simulink model and verify answers by using coding M file or command window. By referring to the answers in 2A, we have to comment about the response obtained. So as you can see, this is the schematic diagram whereby the resistor 1 is 10 kilo ohm, resistor 2 is 10 kilo ohm, the inductance is 200 H, the capacitance is 1000 microfarad, and this is the VOS and this is the VT. So I've already done the calculation manually. So here R1, R2, L1, C1, VOS and VT. So I'm using the formula and I'm using voltage divider rule. So the final answer is 0.1S plus 2S plus 50. So this is the Simulink model and this is the command. The numerator is 1, 0, the denominator is 0.1, 2 and 50. This is the numerator, denominator, this is the step G. So I'm going to copy paste this command into MATLAB. Okay, so this is the response. So for that I have to include the peak response, settling time and rise time and steady state. So this is the okay. So for the peak amplitude is 0.257, the overshoot is INF, at time seconds is 0.553. System is G, the rise time is 0, the settling time is 0. So I cancel this, and this is the graph for 1, and the comment about this is based on the graph it can be described as underdamped because the response is oscillating until it reaches the final value. The rise time of the system is 0, peak time of the system is 0.25 and the time is 0.553 seconds. Settling time is time required for the response damped oscillation to reach and stay within the steady state value. So the settling time for this response is 0.439 and the state of this response is 0. So now let's jump to section B. This is section B, and for section B we have to consider following second order closed loop system. So this is 1 over S, this is 16 as the numerator, S square plus 8S plus 16 as denominator, this is CS. So we have to convert this into our command and we have to execute it. I'll just minimize it. So this is the Simulink model, step 16, S square 8S plus 16, and this is the scope. I've used the transfer function with initial outputs block. So this is the command, and this is the characteristics, settling time, rise time and steady state. So that is so for this basically the system is rise time is 1.1 seconds and the settling time is 1.96, the final value is 1. So this is the step response for this question. As you can see, this is the step response. For the other part, whereby we have to find the fold and zero map. To do this again, this is the pole zero map. So sorry, so just this point and this point here, and the next part is number 2. For number 2, this is the step, this is transfer function initial output, this is the scope, 16 is the numerator, denominator is s square plus 16. So we have to convert this into command. So this is numerator 16, denominator 1, 0 and 16, and this is the numerator and denominator. This is step G, and I'm gonna demonstrate it here. And to be more clear, this is the response. So for a pole zero map, this is the one. Point is here, this is the point, and this is the Simulink model and the graph. So the numerator is 16, s square plus 5s plus 16, this is the scope. So I'll demonstrate it. Okay, go here. This is the one. We have to put in peak response, we have to put in settling time, we have to put in rise time, and we have to put in steady state. So let's click on it. This rise time is 0.479, the peak amplitude is 1.08, overshoot is 8.08, at time 1.01, settling time is 1.5, and we have to go for the pole zero map. So here, this is the pole zero map. This is system. And as for number 4, 20 s square plus 9s 20. This is the denominator, this is the numerator. Step, scope, this is the graph derived from the Simulink model, and this is the coding. I'll paste it here, enter. We have to insert the peak response, we have to insert the settling time, rise time, steady state. So here the rise time is 0.758, the settling time is 1.32, the final value is 1. So this is it. Now we have to go for the pole zero map. This is the pole zero map. The one, pole is -4, pole is -5, damping is 1, damping is 1, overshoot is 0, 0, frequency is 5, frequency is 4. So now let us move on to justification. So the location of poles from figure 3a shows that it is critically damped. This is because two equal poles are located at the same point in the real axis. The value of zeta is equals to 1. The damping factor is equals to 1. As for B, the location of poles from figure 3b show that is undamped. This is because the two poles located at the imaginary axis, the value of zeta is equals to 0. The value of damping factor is equals to 0. The location of poles from figure 3c show that is underdamped. This is complex conjugate poles which are located in the real axis and the imaginary axis, and the value of zeta is greater than or equals 0 and less than 1. The value of damping factor is 0.625. The location of poles from figure 3D shows that is overdamped. This is because the two poles are negative and located in the real axis. The value of zeta is more than 1. The damping factor value is equals to 1. So as for discussion, I'll just minimize it so it's easier. For section A, based on the transfer function answer, the graph obtained from the Simulink model is critically underdamped, whereby the graph has the fastest time rise and fastest settling time. From the graph obtained from the output of the mfile command window shows in detail and clear of the movement of the graph because the time limit was at 0.5 seconds. However, the time limit at the Simulink graph was at 10 seconds. For section B, the figure 2a and 3a show that the graph is critically damped, whereby the graph has the fastest time and the fastest settling time compared to other questions. This questions A only took 2 seconds to achieve the settling time. The figure 2b and 3b shows that the graph is undamped. This is because the output graph was kept on oscillating with no settling time. The figure 2c and 3c shows that the graph is underdamped. The output graph has the high rise time but took longer time settling compared to the fourth question. The last question, the figure 2d and 3d shows that the graph is overdamped, whereby the output graph has a slow rise time and settling time. In conclusion, the software analysis of using Simulink MATLAB have discussed in both section A and section B in this lab. Besides the output response using the input step mfile command window, the method of plotting the pole have been learned from section B. So from section A, the method to derive the transfer function from the electrical network, then with the answer the way to get through the output graph using step input and mfile command window have been discussed. Therefore, all the objectives of this experiment have been achieved. So I guess that's it from me. With that, thank you and have a nice day.